In this video, we're going to go through the first example where you will be drawing either a heating or cooling curve. So I have the directions on the right side and I have the activity on the left side. So if you're doing this in class, you may be doing this on paper. I'm going to be doing it digitally. So for the first example, it says draw a heating curve using the following information. The y-axis should start at negative 20 degrees. Okay, so on our axis, we're going to want to label this, so negative 20. Okay, and we want to end at 120. Okay, so I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Looks like I have about 25 boxes. Okay, so I'm going to go ahead and go by tens. Okay, so negative 20. So this next line would be negative 10. This line here would be 0. I'm going to skip every other line so it doesn't get too messy here. Okay, so this would be 40. You just want to make sure that they're spread out here. 60, 80. Let's do 100 here. And 120. Okay, I could keep going. I'm going to go ahead and do that. So it says it should end at 120. I just want to make sure that I have enough space there to get everything. So I'm going to just go ahead and label all of my boxes here. And let's do 220. Okay. So I went a little bit further than I needed to, and that's okay. All right. The boiling point is 100, and the freezing point is 0. So I'm going to add a line here. We know that we're going to start down here at negative 20, and it's a heating curve, so I'm going to start as a solid, and it's going to freeze at 0. So I'm going to extend my diagonal up. Now, I went 4 boxes over. You can do this however you want. I could have gone 2 boxes over. You just want to make sure that you have some space here. Okay. Now, anytime you have a phase change, that is a horizontal line. So I'm going to go about 4 or 5 boxes over. That's my plateau. That's my phase change where I go from solid to liquid. And then I'm going to need another diagonal here. It says my boiling point is 100, so I'm going to stretch this up to 100. Okay. And then my phase change going from solid to gas. I'm going to have another plateau here. And then finally, I just need this to extend off into infinity because now I'm in the gas phase. Okay, so it says label where it's a solid, liquid, and gas. So that's going to be my next step. So anytime we have, let me use a different color. Anytime we have a diagonal, that is going to be a phase. Oops, that should be solid. So since this is a heating curve, we start as a solid. Then we're going to be a liquid. And then we are going to be a gas. So everywhere we have a diagonal is a state of matter. Anywhere we have a plateau is a phase change. Okay, it says label the following locations. Point A, the substance is 100% solid. Okay, so my first point, point A, will be right there. Oops, let's make that a little bit bigger. So point A will be right here. And let's do a different color here. So this will be point A. And you're going to be doing this on paper maybe, so it might be a little bit different. Okay. Substance is 100% solid at 0 degrees. Oh, I'm sorry. The first point should have been down here. Let me move that over. So I'm 100% solid at negative 20. The next point, point B, is 100% solid at 0 degrees. So I'm going to put that point right there. Point C, 100% liquid at 0 degrees. So here I'm 100% solid. If I go all the way to the other side of that plateau, point C is where I'm going to be 100% liquid. Halfway between point B and C, I would be 50% solid and 50% liquid. Okay, point D, the substance is 100% liquid at 100 degrees. Okay, so 100% liquid at 100 degrees. So on that plateau, I'm closer to the liquid side. And then point E, 100% gas at 100 degrees. Right there. Put that down there. And then point F, 100% gas at 120 degrees. Right there. So that is point F. Okay. All right. So then on the table, you're going to be answering some questions. So they're written down below. So it says, what is the melting point of the substance? Okay. So we labeled the freezing point. Okay. The freezing point is this line right here. And freezing is where you go from solid to liquid. Melting is where you go from liquid to solid. So they're going to be the same point here. So that is also going to be 0 degrees. Oops. I don't have the little degree symbol on my keyboard, so I'm just going to use a star there. What is the condensation point? So we know it boils, where it goes from liquid to gas at 100 degrees. Condensation is where you go the other way, where you go from gas to liquid. So it's going to be the same point. So it's going to be 100 degrees. Which line segment shows a phase where both liquids and solids exist? Well, that's this line right here. So to label the line segment, I have point B and C. It's between points B and C. So I'm going to call it the segment BC. And to indicate a line segment in math, we put a line over the top of it. So I will just annotate it like that. All right, which line segment shows a phase change where both liquids and gases exist? Okay, so where we change from liquid to gas is this segment right here. So that is segment DE. Just like that. At which point does the liquid phase begin to increase in temperature? So B, we're 100% solid. C, we're 100% liquid. Okay, so C is where we start to increase temperature. Okay, point C. Okay, because we're 100% liquid, and then we can start increasing in temperature there. At which point does the gas phase begin to increase in temperature? So we have 2 points that are on the gas phase. We have E and F. So E is where we've completely changed into a gas and we're ready to start changing temperature. F is we've already changed the temperature by, looks like 20 degrees. So E is going to be that first point where we're gas and we're ready to start increasing the temperature. During which line segments are there phase changes? Include all that apply. So we know that anytime we have a plateau or a flat line, we have a phase change. So that'll be BC, and that'll also be DE. And again, to indicate a line segment, let's just throw that line over our letters. And then the last one. During which line segments is there an increase in kinetic energy? Include all that apply. So increases in kinetic energy occur anytime we have a diagonal. Okay, so any diagonal is going to be a change in kinetic energy. So we have AB, that's a diagonal. We also have CD, and then we have EF. Okay, EF. I know that I kind of extended that last line a little bit further than I needed to, but those are my 3 line segments, and I'll just throw a comment in there. Okay, so that's the first example. So what I'm asking you to do is the second example here. So you've got directions right here. You've got a blank slate right here. It's going to be very similar, except it is a cooling curve this time. So you're going to be going the opposite direction. All right, good luck and have fun.